this together for FanDuel to kind of illustrate the architecture that we're using, and figured I might as well pitch it here too. But it's pretty close to the official like Android MAD architecture recommendations. We have a few like small variations from that, but I think it's helpful for someone that's not familiar to kind of see it in action and know how it works a little bit. But this is a slide. I've got a bunch of animations on it to kind of show uh, how our architecture works and how we model state and reflect that in UI and stuff like that. But at FanDuel, we use a VM to hold our state. And then this slide shows like
you're not sharing screen.
Sharing your screen?
yeah.
Yeah.
Let's go back to Zoom. Thank you. Cool. Yeah, so this is just kind of an illustration of our architecture that we're using, which is basically MAD architecture. So we've got this big purple box is our view model. Then this is a really simple illustration of a UI that's showing like contest count and how many contests there are. So those are the main two components, is our view model and our UI. View model holds the state. It also takes in actions from the UI, such as like refresh as an example of an action. And then the VM, I guess one thing that is important to note here is this is kind of flexible. So you can, like, architecture is not like a black and white thing. It's kind of more like a sliding scale. So you can add more components to your architecture as things get more complex, and keep it that way. So simple things can stay simple, and as they get more complex, you can add the components in you need to prevent like 1,000-line view models and things like that, and keep things maintainable. So VM is going to contain most of the like business logic, and it's holding the state. So in the case where it gets more complex, you can add in optional use cases, which are like abstractions of single situations of business logic, I guess you can say. So for example, you might have a use case that in this example would go out and get your contest count, for example. This is a pretty simple example, so it's probably not worth putting in use cases, but as you get more complex, you can add those in. And then use cases can talk to repositories, which are an abstraction of retrieving data. And then repositories can make the decision of, yep, I need to go get remote data, or I need to get local data from memory or wherever, with different data sources, which are also optional. So you kind of, based on how complex your feature is, you decide what you need, and you can always add in later as needed. But yeah, this example shows contest count. So in its current state, we have the state provided by the VM, and the contest count is 0, and our UI is idle. So in the case where the user wants to do a refresh, they might click a refresh button, and a refresh action is going to be sent over to the view model. And from there, the view model is going to see, okay, I need to refresh, and it's going to change the state. So we still have 0 contests, but now we're loading. So the view model tells the UI that it's now loading, and the UI reflects that state. So from there, the VM says, okay, I've told the UI that I'm refreshing, but I haven't actually refreshed yet. So it's going to send that on to a use case and say, okay, I need to get my contest count. The use case is going to ask a repository for that data. And the repository is going to say, okay, in this case, I want to go grab that from the network. and send it to a remote data source. And then from there, you're going to make your normal like HP get request or however you get your contest count. And let's just say that comes back with 1 as the contest count. And for now, I'm going to kind of gloss over this, but on the way back through, you generally want to keep your models separate. So you would have a model that represents your API contract, for example, of contest count. And that should be a representation of your contract there. And as it goes back through, you should map that to what you care about. So in that case, your model for the backend contract, if that contract changes, it doesn't flow all the way back through your system. You can just map it differently in the repository layer or like your use case domain layer. So that all happens on the way back. And that's kind of optional too. Like best case scenario, you have models for each layer of your architecture to keep them decoupled more. But in my opinion, it's fine to take shortcuts sometimes. And as long as you have, I think it's important to have a model that represents your contract. And then if you want to take a shortcut and send it the same model the rest of the way through, I don't think that's a huge deal. But if you want to be a purist, you should probably have models for each layer. And that's where you get into like a lot of overhead for mapping and things like that. So now we're back in our VM. We've made the request and it's come all the way back through all the mappings. And the VM now sees that we have 1 contest here. So the VM is going to change our state to we have 1 contest and we're now idle. So from there, the UI is going to be observing that state. And we now have a UI representation of that state object was 1, and it's now idle. So the main important part here is this unidirectional flow between the UI and the VM. The UI observes the state from the VM, and then actions come back into the state, and the VM updates the state based on those actions. And then one interesting thing is actions don't always have to originate from the UI. There can be cases where the VM needs to tell the UI to take an action. Like in the example of, let's say it has to show a toast or navigate to an activity if you use multiple activities, something like that should be handled in the UI. We always think about how that can be modeled in state. So one example would be if we need to show a screen that requires login, we could have is logged in our state. And if that ever comes down as false to our UI, then the UI would know that, okay, I need to send this user to our login screen, and it could perform that action. And that's kind of an example of like a fire and forget state, but there are times where you might have a chance of getting back back to your UI, and you have to think about where you leave your state in that case. Like in the example of showing a toast, you might have like a list of messages that the UI needs to toast. So the UI will see that there's, hey, I've got a message in my list, so I'm going to toast that. And then the UI would need to actually communicate back to the VM, okay, this has been shown, we're good to go. And then the VM would actually remove that from the state. So it could, the UI is always a reflection of how many messages are in there, if that makes sense. So that's most of what I have here. Does anyone have any questions? Definitely want to discuss this a little bit.
What's your actions look like? Is that
Yep.
just calling into your view model and you're exposing a thing, or is that something where you're actually exposing available actions and maybe something, and then it like is a single method that you're passing actions to?
Yep. So good call. Wanted that to come up. So in the architecture series, you'll see most of the time, like the Android team exposes functions on their VM and the UI calls those functions, right? That's one area where we're a little bit different is we like our VM contracts always have we use a state flow for our state, and then we have one function that takes an action, and then our VM exposes specific actions to the UI. So the UI knows exactly which actions the VM is capable of. So we use like a sealed interface that says this VM can do navigate to login, or this VM can do show a message or whatever.
What would you say the pros and cons of just exposing the level of actions to the view versus exposing the functions directly? Is there some advantage you see there?
Yeah, I feel like it's worked out really well for us because you can kind of like compose those actions as you go down the composable chain too. Like at the top level, you have all of your actions, right? So your VM says I can handle these actions, and then you might have a sub-composable that has sub-actions, and you can kind of compose it in a way that the sub-composable only knows about those actions. And I feel like it keeps our composables cleaner because like if you don't do that, then as you go down the chain, you might have composables that take like 10 functions in, right? Instead of one function with 10 actions.
Yep, that makes sense.
Yeah.
It's also easier to understand what's going on the screen, because then you have one place where you have all the actions instead of being model about like
Right. Yeah. Right. Yeah.
So let's say my action leads to opening it at like a browser or something and it goes off screen. Where do you do that logic and how do you handle that when it gets back? I'm just asking a question, fortunately.
Yeah.
Don't you work
So-
with him?
I didn't say
So-
that.
So you have an action that needs to go off screen. I mean, I think you would do it the same way where like you tell the UI, here's the action, this needs to happen. The UI communicates back, yep, this happened, and then you're done, right? Or
If you're watching the state flow in your view,
right,
and then you say start activity or whatever it is,
yep,
and then when they hit back or something, then
It sounds like what he's doing is at the top most thing that receive like there's basically something that enumerates every sealed class action and basically would launch the Chrome tab or whatever, right?
Mhm.
And then when he gets called in there, then he probably I don't know when you clear that in the single state, if you do it like if you call another action, or if you when the action gets called, so you call another action.
Yep.
Yeah, so he just called another action.
Yeah.
Once that makes sense. That's
You send an action
basically-
back to the VM
yeah, that
that
makes sense.
clears that state that the UI is watching for doing the launch.
Yep. We did this similar stuff, but without
Cool.
a sealed class, we did a view model.
Yeah. Yeah, so one thing we've kind of learned, like we used to model this with like flags, and then we were finding that sometimes we needed to also send data down. So we would have a flag that's like pending WebView launch in that example.
idea,
Yeah, and then we
So-
would
that fake.
and then we would have like, here's your URL you need to launch, for example. as a different item on the state. So it'd see, okay, I'm pending launch, I need to launch, here's my URL. We kind of switched and now we do something more like we do sealed interface. I'll just call it action for now, and we do like object idle, and then we do like you might do data class triggered, and then that could take the URL string or whatever data you have, and then this gets stored on your state. So now you just watch like, am I idle or am I triggered? And if I'm triggered, here's my URL. I'm going to launch with that URL. So that kind of kept our actions from exploding. Like you're watching for the sealed class now, and when you're triggered, you have the data right there versus having that data flattened out onto your state.
But you need an array of actions though, right? In your view model, right? Of like uncleared actions, right?
We typically don't, but you probably do for things like
if you want to show an array of snack bars, unless
Yes.
you have your snack bars as an array in the action somehow.
Yeah.
I guess you could model it either way, I guess.
right.
Well, I think the most important part is that once you do the trigger, you still have to call back and say, hey, now go back idle, instead of like leave it that way, right?
Yeah.
And this is different in that how we used to have it, how you described it was like just a whole bunch of very specific flags saying we literally called like is pending this action. And so we'd have like a whole bunch of these, where now we just have trigger the action and then just go right back to the idle state instead of like having to have all these lists.
Would you have multiple data classes inside of this?
You could.
Well, I mean, like, let's say you had to do 5 different actions. How would you model this? They're completely separate. Like,
Yeah,
would
you
would
could.
you put them all in here? That like what you're suggesting?
Um,
So like, if you did them all in here, what would idle? Idle is not. Yeah, I'm just a little confused on how you model this, because like essentially you can potentially have 5 actions that are pending, right?
right.
So how do you clear that and set it to idle? Because you can't just from the view model say, hey, trigger something happened,
Mhm.
but trigger something else didn't happen. But I'm gonna sit
Right.
back and idle. How do you know I'm clearing trigger something?
Well, the action's going to be specific. So I guess it depends on what you're after. Like there's definitely going to be some drawbacks of this approach.
Well, were you gonna explain it? 'Cause I feel like
Oh, go ahead.
we talked about it.
Yeah.
This could be just one action with an idle and then your trigger.
Yeah.
And then you can have another sealed interface or whatever, where it could be your second action with idle and trigger. And so because of the named interfaces, you know exactly what action you're triggering. And so if you need multiple, that's the thing, if you need multiple actions to happen at the same time, which is, I feel like rare in how we use menus, then you can do it that way. But this works for like, I tap this, now it's this action's triggered. You really don't use simultaneous actions a ton in just normal navigation.
Yeah, and that's the drawback I was getting at. Like I feel like
Sorry.
in most cases you can get away with this, but in the cases where you need like simultaneous things and like they're not, I guess you could say they're not mutually exclusive, then this wouldn't work. But
we have a lot of events for a similar scenario as we were just talking about, like an intent to open something, but it's largely in the context of like take a picture, like open the gallery, and you want that event to like not persist, right? Because it's not really part of the state. It's more of an event. We all love our old event structures we built back when live data was a thing. But what we use alongside state flows and sealed interfaces for specific mutually exclusive states along our screen, we also use shared flows. And that's essentially just a flow that can have multiple, they don't call them listeners, but like collectors. And that would do exactly what you're describing here. You wouldn't have to like have the UI say, hey, this is completed, or like do that on the VM and say, oh, I emitted it and I'm just going to unemit it. You could just say shared flow, emit this state or this action, and the UI hits it or reacts to it immediately, and there's no persisted state. So like there's a clear delineation between what is persisted and what is like an event. And shared flows are great for that alongside state flows.
Flow doesn't emit its latest thing. It doesn't have like a.
There's no persistence in it. It's like a hot stream of data. And it works really well for that scenario. Because like in my day job, we have essentially one screen with hundreds of different states that are going on, and shared flows have fit the bill really, really well in that scenario.
You can configure them to be stable, like you just set, don't they have just like that replay equals 1?
I think if
You can, but that means when you start collecting, you'll get that last emitted item. What we do is we do shared flow, you do mutable shared flow, and then you give it like an extra buffer of 1 so that you don't have to like open up a coroutine to emit something. You can just say, hey, go emit this, and anyone who's listening can react to it. Otherwise, I don't really care about it persisting because it just happened. So we do that for like intents, and we also do it for like error, like deep core code that wants to emit errors. It's not like a persistent state. It's just something that say, hey, like I just came across this it's not like a crash, but it's an error that we just handled. Emit that up, bubble it up to the UI, and if a logger wants to react to it, it can.
From my understanding, like shared flows are like not the recommended way to like, unless if you're okay with users not seeing it, then it's fine. But if you want to ensure your users see it, like a shared flow is not really a good way to do that, because it's going to basically nothing could be observing it. Your UI could not be there. So like it's possible to drop state. Is it really a big problem? Probably not, but like I think it's generally recommended to put stuff in a single or some sort of state flow that you have something that triggers back to tell it to clear it after it gets shown.
It's sure case by case. It's just like, the old event bus we used to abuse way back in the day. It's just like a fire and forget thing that doesn't really exist in the UI. It's more for like a single event that happened. And it's great for like telemetry events and like intents that you want to not have to manage. We use them all the time and they're fantastic. And you can use stuff like replays. And so if you, in a scenario where you want to like emit multiple, so say you want to emit multiple snack bars for whatever reason, you can like have a buffer capacity that would fit the needs, and then the UI spins up a coroutine and says, oh hey, I just got something, I'm going to react to it, show it, and then once it's done, it'll like then pull the next one. And so there's like this, it's just like the RX world, there's like this collector that has a running list, and it can suspend if it wants to, otherwise it can just keep consuming them, and the shared flow won't emit any more than it can to that active coroutine. It's well worth the discussion, but yeah, we try not to hold the state of like, I want to show the gallery, because you come back to that screen and it opens again. Unless you've cleaned it up, it becomes a problem.
Yeah, that makes sense. So you're essentially saying your view model interface would it be something like this, where you have your state still, and then you also have a UI action channel, which is a shared flow that so the UI would be observing your state and potential actions.
Yeah, there's like a specific class of those actions that we respect as just fire and forget events. But yeah, we have several state flows that manage multiple states, because there's dozens of components that are running their own thing, but that is the gist of it. Yes.
Cool. Makes sense.
Can you go back to your diagram? I want to see if I have any more questions.
Sure.
Let's see here. Do you try to go with a single UI state? Or have you found that approach? I know in the docs it says you don't have to, but do you have a preference towards a single UI state, or do you have a UI state for or are you a little bit more flexible where sometimes you have 5 or 6 UI states?
No, we always have like one top level state, but within that we kind of break it down, and like it's not a flat state. So you might have one UI state, and then you might have a sub-state object that is for this section of the
Are you
street.
collecting multiple times inside one composable? You're
No.
collecting one time and you're just exposing that through where it needs to go.
Yeah.
Okay.
Might say we compose states.